A 40-gram sample of an unknown metal at 80 degrees Celsius is placed in a constant pressure calorimeter containing 60 grams of water at 20 degrees Celsius. The final temperature is 23.5 degrees Celsius. Assume that the heat capacity of the calorimeter equals the heat capacity of the water it contains. Calculate the specific heat capacity of the metal. Okay, so in this problem, we will be using the equation Q hot is equal to negative Q cold. So first, you will identify which one is the hot substance and which one is the cold substance. So in this problem, we have two substances, the metal and water. So how do you determine which one's hot and which one's cold? You look at their initial temperatures. So for the metal, the unknown metal, it is at 80 degrees Celsius and water is at 20 degrees Celsius. So obviously, your hot substance is the metal and your cold substance is water. So our equation would now be Q of the metal is equal to negative Q of water. Okay, so now we all know that Q is equal to mc delta T, right? So what we're going to do is we will expand our equation. We will substitute mc delta T into the equation. So on the left side now becomes mass of the metal times C of the metal times delta T of the metal. And the right side now becomes negative mass of water times C of water times delta T of water. Okay, now all we have to do is just substitute the values given in the problem. So the mass of the metal, let's start with the left side. The mass of the metal is 40 grams. So that's 40.0 grams times C of metal. So we don't know that because we're looking for the C of metal. It says calculate the specific heat capacity of the metal. So it's unknown. We don't know yet the C of metal. So just write C of metal times the change in temperature of the metal. So that's final temperature minus initial temperature. So the final temperature given in the problem is 23.5 degrees Celsius. And the initial temperature of the metal is 80 degrees Celsius. So what's 23.5 minus 80? So that's approximately, or not approximately, but equal to negative 56.5 degrees Celsius. So we're done with the left side. Now let's move on to the right side. So negative M of water. So the mass of water is 60 grams. So 60 grams of water times the C of water. So what's the specific heat capacity of water? So it's not given in the problem, right? But you should memorize or you should be familiar with the specific heat capacity of water in case it's not given in the problem. So the specific heat capacity of water, that's 4.184 joules per gram degree Celsius. Again, if it's not given in the problem, you should have memorized the specific heat capacity of water. Times the change in temperature. So again, it's final temperature minus initial temperature. The final temperature according to the problem is 23.5 degrees Celsius minus the initial temperature of water, which is 20 degrees Celsius. So 23.5 minus 20, the change in temperature for water is 3.5 degrees Celsius. So to solve for the C of metal, all you have to do is divide both sides of the equation by 40 grams times negative 56.5 degrees Celsius. So as you can see, 40 grams will cancel on the left side as well as negative 56.5. So what's left on the left side is just the C of metal. On the right side, all you have to do is plug in everything in your calculator. So negative 60 times 4.184 times 3.5 divided by 40 times negative 56.5. So you will get approximately 0.389. So let's check the units. So grams will cancel, degrees Celsius will cancel. So the unit is joules per gram degree Celsius. So this is the C, or the specific heat capacity of the metal, and the answer to the question.